July 18, 1944, St. Lo, France, 0647 hours. Corporal James Donovan's Sherman tank roared across the Norman countryside at 15 miles per hour, engine screaming, hull bouncing violently over crater-pocked earth. Through his gunner's sight, 800 yards distant, a German Panther emerged from the tree line, also moving. Every manual, every training session, every doctrine memo said the same thing: stop completely before firing. A moving tank cannot hit a moving target. Physics doesn't allow it. Donovan's hands moved across the traverse and elevation wheels. The turret swung smoothly, impossibly smoothly, tracking the Panther despite the violent bouncing beneath him. His custom contraption of scavenged springs and hydraulic lines absorbed each jolt, keeping the gun steady. His finger touched the trigger. Radio chatter exploded. Able 3, halt before engaging. Repeat, halt before. He fired. 2.3 seconds of flight time. The 75mm shell struck the Panther's turret ring, dead center. Fire erupted. Metal screamed. The German tank shuddered and stopped, smoke pouring from every hatch. Nobody believed what they just witnessed. The summer of 1944 had become a killing ground for American armor. In Normandy's hedgerow country, Sherman tanks fought at a brutal disadvantage. The tactical reality was simple and deadly. To fire accurately, a Sherman had to stop completely, engine idling, hull motionless, gunner waiting for the perfect moment of stillness. German tanks had no such limitation. Panthers and Tigers could engage while maneuvering, their superior guns and armor turning every encounter into an execution. American tankers in the 2nd and 3rd Armored Divisions were suffering casualty rates exceeding 60% in some units. The bocage terrain, ancient earthen walls lined with thick hedgerows, transformed every field into a maze of ambush points, where stationary targets died first. The bitter irony haunted every crew. Sherman tanks actually possessed gyroscopic stabilizers. Westinghouse had designed them specifically for firing on the move, but the systems failed constantly. Gyros drifted, electronics shorted, hydraulic lines leaked. By July, maintenance officers estimated 70% of all stabilizers had been disabled by their own crews. The technology existed. It just didn't work. James Donovan grew up in Bridgeport, Connecticut, where precision wasn't a goal, it was a religion. The city's factories produced everything from sewing machines to firearms, and every part had to fit within tolerances measured in thousandths of an inch. By age 16, Donovan was running lathes at Remington Arms, machining rifle components that required microscope-level accuracy. He was quiet, methodical, the kind of worker who triple-checked measurements and kept immaculate notebooks filled with calculations and sketches. His co-workers called him the professor because he treated every job like a mathematics problem waiting to be solved. When Pearl Harbor shattered America's peacetime illusions, Donovan volunteered immediately. Fort Knox trained him as a tank gunner, but his mechanical background caught the attention of maintenance officers. They wanted him in the repair depot. He refused. He'd enlisted to fight, not fix. By June 1944, Corporal Donovan was a gunner in the 3rd Armored Division, rolling off the Normandy beaches into history's bloodiest hedgerow country. His tank crew nicknamed him the Machinist, after watching him disassemble and rebuild their Sherman's breech mechanism in complete darkness. They had no idea what he was planning. The Westinghouse gyro stabilizer was brilliant in theory. A spinning gyroscope detected the tank's pitch and roll, sending electrical signals to hydraulic actuators that counteracted movement, keeping the gun barrel stable regardless of terrain. On paper, it was revolutionary. In practice, it was a mechanical nightmare. The gyroscope suffered from precession drift, errors that accumulated over time, causing the gun to wander off target. Temperature changes affected the hydraulic fluid viscosity. Electrical connections corroded in the damp European climate. Power surges from the tank's generators fried control circuits. And when components failed, they failed catastrophically, sometimes locking the turret completely. Field maintenance couldn't fix them. Replacement parts didn't exist. Engineers at ordnance depots threw up their hands. The official solution became standard across American Army units. Disconnect the stabilizer entirely. Return to manual operation. Stop before firing. Donovan watched 3 Shermans, his battalion, burn in a single week, all caught stationary while their gunners waited for that moment of perfect stillness. He'd seen the disabled stabilizer components in his own tank, complex assemblies gathering dust, representing hundreds of engineering hours rendered useless by unreliability. The Army had built the answer. They just couldn't make it work. Donovan's insight came during a midnight maintenance session. The problem wasn't the concept of stabilization. It was the overcomplicated electronics and finicky gyroscopes. What if he could achieve the same result through purely mechanical means? He started sketching. Springs instead of hydraulics. Counterweights instead of gyros. A damping system that absorbed vibration through physical mass rather than electrical signals. For 3 weeks, he worked every evening behind the supply depot. Materials came from battlefield salvage, leaf springs from a destroyed truck, hydraulic lines from a burned-out half-track. Steel plate he cut and filed by hand. He borrowed an arc welder from an engineer unit, trading cigarettes for access. The contraption grew slowly, a framework of springs mounted to gun's elevation mechanism, connected to a fluid-filled damper he machined from a hydraulic cylinder. Other gunners gathered to watch, shaking their heads. Connecticut's building a perpetual motion machine. One laughed. "Hey, machinist, that thing gonna make coffee too?" His tank commander, Lieutenant Shaw, was more diplomatic. "Donovan, I admire the initiative, but if maintenance sees this, they'll have both our stripes." Donovan kept working. "Won't matter if it doesn't work, sir." The practice range sat 2 miles behind the front lines, far enough from combat to be safe, close enough that nobody asked too many questions. Donovan ran tests during off-duty hours. His tank driver, a farm kid from Iowa named Eddie Kowalski, the only believer in the crew. Initial results were disaster. The springs were too stiff, causing the gun to bounce harder. He recalculated, replaced them with softer coils. Too loose now. The barrel wobbled unpredictably. He adjusted the damper fluid viscosity, adding heavier oil to slow the oscillation. Slowly and possibly it began working. At 5 miles per hour, he hit a stationary target. At 10, he managed a moving truck. By the 3rd week, his accuracy reached 60% on mobile targets, 12 times better than standard doctrine allowed. Word spread quietly. The machinist actually onto something. The battalion gunnery officer remained skeptical. "Field modifications violate regulations, Corporal. If your contraption fails in combat and costs lives, it's court-martial territory." Donovan showed him the test results. The officer studied them, said nothing, and walked away. Lieutenant Shaw pulled Donovan aside the night before Operation Cobra launched. "Keep it installed. We'll handle the paperwork later. If we're alive." Dawn broke over St. Lo with mist clinging to the shattered hedgerows. Diesel fumes mixed with coffee steam as the 3rd Armored Division assembled for the breakout offensive. Donovan sat in his gunner's seat, running through pre-battle rituals that had become sacred. Check ammunition, verify traverse mechanism, test electrical circuits, inspect his stabilizer one final time. The springs showed no stress cracks. The damper fluid level was perfect. Every bolt was torqued precisely. Radio crackle filled his headset. "All able units, advance through Gap Alpha on my mark. Engage enemy armor on sight. Over." The Sherman lurched forward, joining a column of 30 tanks rolling toward the German lines. Morning light filtered through smoke and dust, casting long shadows across cratered fields. Track clatter, engine roar, the metallic smell of oil and cordite. Sensations Donovan had learned to ignore, focusing instead on the mechanisms around him. His stabilizer swayed gently with the tank's movement, springs compressing and extending in smooth rhythm. Lieutenant Shaw's voice came through the intercom. "Donovan, remember standard procedure. We stop before firing." "Clear." "Roger that, sir." But Donovan's hands rested on the traverse wheel, and his eyes scanned the tree lane ahead, and somewhere in his Connecticut toolmaker's mind, he knew that doctrine was about to meet reality. The Panther materialized like a ghost, hull down behind an earthen berm, turret traversing, searching, 800 yards. Moving left at 12 miles per hour, heading for cover. Target, Panzer, 10 o'clock. Shaw's voice cracked with urgency. Driver, halt. Gunner, prepare to. But Donovan had already seen it. Already calculated intercept angle, lead time, elevation compensation. His hands moved with machinist precision. Traverse wheel spinning. The turret tracking smooth as silk despite the Sherman's violent bouncing. The stabilizer absorbed every jolt. Springs compressed and released in perfect harmony. The gun barrel stayed locked on target. Shaw was still shouting, "Donovan, I said halt before." Donovan squeezed the trigger. The 75-millimeter gun roared. Recoil slammed backward, but the stabilizer held, keeping the sight picture steady enough to watch the shell's flight. 2.3 seconds across 800 yards of summer air. Impact. The armor-piercing round struck the Panther's turret ring, the weak point where turret met hull, and penetrated. Fire erupted instantly, ammunition cooking off in a cascade of secondary explosions. The German tank lurched sideways, smoke pouring from every opening. Radio silence. Then chaos. Did Able 3 just hit a moving target? From a moving tank. Negative, must have been stationary. Physics doesn't. Shaw's voice, quiet with disbelief. "Donovan, what the hell just happened?" "Stabilizer works, sir." By nightfall, Donovan's Sherman had scored for confirmed kills. Everyone fired while moving, every shot hitting targets that were themselves maneuvering. Word spread to the 3rd Armored Division faster than radio reports. Connecticut's got something, some kind of magic gun. Battalion Command summoned Lieutenant Shaw. The gunnery officer who dismissed Donovan's contraption now demanded every technical detail. Ordnance officers descended on the tank, initially to confiscate the unauthorized modification, but stopped when they saw the spring and damper assembly still warm from battle. "This is..." The senior engineer ran his hand along the mechanism. "This is actually more reliable than the Westinghouse system." Other tank commanders surrounded Donovan. The mockery had evaporated, replaced by desperate urgency. "Can you build more?" "How fast?" "My crew's been slaughtered 3 times over because we have to stop to shoot." The question went up the chain. By week's end, Donovan was training mechanics across the division, teaching them to scavenge materials and replicate his design. It wasn't perfect. It wasn't pretty, but it worked. And in the hedgerows of Normandy, working mattered more than regulations. Operation Cobra's success owed itself to many factors, but the increased armor effectiveness, the ability to engage while maneuvering, gave American tanks an edge they desperately needed. One corporal's unauthorized innovation became tactical doctrine. James Donovan returned to Bridgeport in October 1945, trading his tank for a lathe at Remington Arms. He married a nurse he'd known before the war, raised 2 children in a modest house 3 blocks from the factory, and rarely discussed his military service. When asked, he'd shrug, "Just did my job." The Army documented his field modification in technical manuals updated for the next generation of armored vehicles. Post-war stabilizer development. The systems that would eventually equip M60 Pattons and M1 Abrams tanks. Incorporated principles Donovan had discovered with scrap metal and borrowed tools, mechanical damping, redundant systems, simplicity over complexity. He died in 1982, his obituary mentioning military service in a single line. No medals, no headlines. History books about armored warfare development occasionally reference field modifications by enlisted personnel without naming names. But somewhere in the lineage of American tank doctrine, in the sophisticated stabilization systems that allow modern tanks to fire accurately at 40 miles per hour, lives the ghost of a Connecticut machinist who refused to accept that impossible meant permanent. Innovation doesn't wait for permission. Expertise doesn't always wear stars. And sometimes the most revolutionary solutions come from the people actually doing the work, the ones close enough to the problem to see what the manuals miss. Maybe you're holding your own version of those scavenged springs. The question isn't whether it's authorized. The question is whether it works.